Hello everyone, welcome back to my channel Ncert Maths with Bardeep. Today we are going to start a new chapter of your grade 10, that is chapter number 8, Introduction to Trigonometry. So this is an introduction video in which we will cover all the important topics of this chapter. Before starting the chapter, I want to clear one doubt of students. Mostly they will feel that trigonometry is very difficult. So please don't have that idea that this is going to be very difficult. I'll make sure that if you follow all the steps that I'm going to explain, this chapter is going to be very easy. Okay. So now let's start the introduction of this chapter. First of all, what is the meaning of trigonometry? So trigonometry is derived from Greek words. So this can be split into three different words, that is tri, gono and metry. Tri means three, gon means sides, and metron means measures. So basically trigonometry is the study of relationship between the sides and the angles of a triangle. We will use certain concept in which we can find the relationship between the three sides of a triangle, and it can be used in many different applications. Okay, so we are going to study in detail. What does this mean? That basically we will always consider one right angle triangle, okay, and then three angles. We already know that a triangle has three sides and three angles. So one of the angles should always be a right angle. In trigonometry, we will consider the length of the three sides of a triangle, the angles between them. Any two sides will be given to us, some angle will be given to us, and we will find the third side. So trigonometry has many applications, like it is used to find the distances of the stars and other planets from Earth. Second is, we are standing at a distance from a building and we want to know the height of that building. In that case also we will use trigonometry. Suppose this is the building and I am standing here. I don't know what is the height of this building, but I know this distance. Okay. So since building is upright, so this will be a right angle, and we will join this point and see we will have a triangle. So now we will relate the length of the sides with angles and we can find the height of your building. Similarly, we have many other applications which we are going to study in our next chapter, that is chapter number 9. Now let's see the first main topic of this chapter. So now let's see what are trigonometric ratios. Always make sure that whenever we are talking about trigonometry, the triangle that is under consideration is always a right angle triangle. Suppose I am taking this triangle, that is ABC, which is right angled at B. Okay, then A and angle C are acute angles. Why? Because we know that sum of angle A plus B plus C is 180 degree, that is angle sum property of a triangle. So out of 180, angle B is always 90 degree, or any one angle is always 90 degree. So this means that this is 90, then the sum of the remaining two angles is also 90 degree. So since A plus C is equal to 90 degree, that means sum of two different angles are 90 degree. So this means that A and C will always be an acute angle. Okay, what are acute angles? Those angles whose measure is always less than 90 degree. If two angles are adding up to 90 degree, that means individually both angles will be less than 90 degree. So this is the case that we will always consider, that is one angle should be 90 degree. Then automatically remaining two angles will be complementary angles. So now let's understand the different terms that we are going to use in this chapter. In this right angle triangle, which is right angled at B, we have two other angles, that is angle A and angle C. Okay, so right now I am taking angle A. Before that, we all know that in a right angle triangle, the side that is opposite to 90 degree is always referred as hypotenuse. Okay, and these two sides, that is AB and BC, any one can be base and the second one will be perpendicular. So generally, so this side is perpendicular and this side is base if we are taking into consideration this side. Okay, for angle A, the side that is opposite to angle A will be referred as perpendicular, and the side which is adjacent with this will be referred as adjacent side. I repeat, if we are considering angle A, okay, so this will be hypotenuse always because this is opposite to angle B, which is a right angle triangle. Okay, so now these two sides we will consider. So out of these two, anyone can be perpendicular, anyone can be base, but there is one condition that whichever angle is under consideration, suppose for angle A, the side which is opposite to angle A, okay, so opposite will be referred as perpendicular, and one side is adjacent with angle A because it is starting from A, so this AB, so AB will be referred as base side, okay, or adjacent side. I repeat, any one angle which is under consideration, we have two options. One side is opposite to that angle, that will be referred as opposite side or perpendicular side, and second side is adjacent with that angle, so that will be referred as base. Okay, so now we will find the relationships between hypotenuse, perpendicular and base of a right angle triangle. But I want to mention another point, that if we consider this angle, okay, that is angle C is under consideration, then we can see that perpendicular and base will interchange. Okay, again hypotenuse will be same for this angle which is the opposite side, that is AB. So now AB will be referred as opposite side or perpendicular. Okay, and this side is adjacent to angle C, so this will be referred as base or adjacent side. I hope this is clear. So what are the terms? That is hypotenuse, base or perpendicular. Perpendicular is also known as opposite side, okay, and base is also referred as adjacent side. This is what I have written here, that if we are considering angle A, this BC is the opposite side, and opposite side of this angle is also referred as perpendicular, and second side is AB, this AB, since we are considering angle A, so this is adjacent to angle A, so this is adjacent side, and adjacent side is also referred as base of a triangle. Okay, so hypotenuse is always fixed, whatever angle is your right angle. So now we will see what are the different trigonometric ratios that we are using in this chapter. So basically there are two different ways how to memorize what are these ratios, that is sine A, cosine A, tangent A, cotangent A, secant A and cosecant A. Okay, I repeat, these are the 6 trigonometric ratios, that is sine A. A means the angle under consideration. It can be sine C if we are considering angle C. So sine A, cos A or cosine A. This is tangent A or tan A. Okay, cot A or cotangent A, secant A, cosecant A. Okay, so now we should know what are these ratios. There are two different ways in which you can memorize these ratios. So one thing is this, our teacher told us during our time, that is PBP over HHB. Now what is P? P will be referred as perpendicular, base as B and hypotenuse as H. Okay, so you should always memorize this, that is PBP over HHB, or there is one acronym for this, that is Pandit Badri Prasad over Har Har Bol. Okay, this is one way of memorizing these trigonometric ratios, simply PBP over HHB, right? Then we will see that this first ratio, that is P over H, will be sine. Okay, B over H will be cos or cosine. Okay, next is P over B, so this will be tangent. So first ratio, that is P by H, is sine, B by H is cosine or cos, and P by B is tangent. Then we will reverse the order, that is this is cotangent or cot, then is secant, and then is cosecant. I repeat, sine, cos, tan, then cot, secant, cosecant. Okay. So if you memorize this formula, you can never be wrong in any ratio that we are going to calculate. So it's very simple. Pandit Badri Prasad over Har Har Bol. That is PBP over HHB. So write this ratio on the rough hand side. Then first one is always sine, cos, tan, and then it is cot, secant, cosecant. Means we will start from this and then we will take this round. Okay. So sine ratio will be always perpendicular over hypotenuse. Cos is always base by hypotenuse. Tan is perpendicular by base. And cot is, now we will read from this side, that is base over perpendicular. For secant, this is hypotenuse over base, and then cosecant, this is hypotenuse over perpendicular. So this is one way. There is second way also, that instead of P and H, we will use opposite side and adjacent side. So let's see sine of A. So first of all, we will see which angle is under consideration, and then we will identify for this angle what is P, what is B, or what is opposite side and what is adjacent side. P is always opposite side, B is always adjacent side. Okay. So now let's see, sine is perpendicular over hypotenuse. We will see for sine A, what is perpendicular? This side, that is BC over hypotenuse. Hypotenuse is AC. So BC over AC is sine of A. Okay. Or we can say what is BC? This is, see, BC is opposite side. So in your textbook it is referred as this, that is opposite over, what is AC? AC is hypotenuse. So opposite over hypotenuse is sine of A. Okay. So this is not read as sin A. This is sine of A. A means the angle under consideration. So next is cosine A or cos A. Cos A is base over hypotenuse. As I already mentioned, base is adjacent side. So what is base or adjacent side? This is AB over hypotenuse. What is hypotenuse? This is AC. Or we can say this is AB is base over hypotenuse. So this is up to you how you want to memorize. So next ratio is tan A or tangent A. Tangent is always the ratio of perpendicular with base. See, tangent is perpendicular over base. What is perpendicular? This is BC and over base. Base is AB. Or we can say opposite over base. Okay, next is cot A or cotangent A. Cotangent A is, see, cot is here, this is base over perpendicular, means the ratios I have written up, it should be read as P over H, B over H, P over B. The ratios which I have written below, it should be read from this side, that is base over perpendicular, hypotenuse over base, and hypotenuse over perpendicular. So this is base over perpendicular. So base is AB and perpendicular is BC. Base over perpendicular, we can say opposite side, right? Next is secant A. Secant A is this thing. So this is hypotenuse over base. So hypotenuse is AC. Base is AB. Okay. So hypotenuse and base sorry, we will write not base, it should be adjacent. Here also adjacent over opposite. So adjacent, wherever is base, you should write adjacent. Here also this is adjacent. Okay, so next is cosecant A. Cosecant A is this hypotenuse over perpendicular. So what is hypotenuse? This is AC over perpendicular. Perpendicular is opposite side. So opposite side is BC. Okay, or we can say hypotenuse over perpendicular. Perpendicular is also referred as opposite. Okay, so these are the 6 trigonometric ratios that we will always use for finding anything in a trigonometry. Okay, I repeat what we have done, that I have written PBP over HHB. If you can memorize this, then trigonometry is very easy. Simply sine, cos, tan, cotangent, secant, cosecant. So sine is ratio of P by H, cos is B by H, tan is P by P. Then cotangent is B by P, secant is H by B, and cosecant is H by P. In your textbook, instead of P, they are using what? Opposite side. And instead of B, that is base, they are referring this as adjacent side. So don't get confused that whether we should use base or perpendicular or opposite side or adjacent side. This is entirely up to you. This is one way of memorizing these ratios. Now we can see that certain ratios are reciprocal of each other. So here you can see sine and cosecant are reciprocal, cos and secant are reciprocal of each other, and tan and cotangent are reciprocal of each other. So here we can see, let's see here cot. See, cot A is AB over BC. So this tan is BC over AB. So this is just the reciprocal of tangent. So there is another rule which we will refer as cot A is always 1 by tan A. This is one thing. Okay. Second is secant. Secant is AC over AB. Now let's see cos. This is AB over AC. Same values but reciprocal of each other. So secant A is reciprocal of cos A. So we can write secant A. This is always 1 over cos A. Right? Next thing is cosecant. Cosecant is AC by BC. So here see sin A. This is again BC by AC. Same values but in reciprocal. So cosecant A is 1 over sin A. See, mostly students will try to memorize this. If you memorize this thing, you can see cosecant is reciprocal of sine, secant is reciprocal of cos, and cot is reciprocal of tan. So this is up to you. This is another formula, that is cot A is 1 by tan A, secant A is 1 by cos A, and cosecant A is 1 by sin A. There is one more thing, that is tan A. There is another relationship between tan A, sin A, and cos A. Tan A is always sin A over cos A. Okay? Ratio of sin by cos will give you tangent A. So let's prove this. What is the value of sin A? This is BC over AC. Okay, so if I write it here, this is BC over AC. Cos A is AB over AC. Okay, so this is AB over AC. So now if you solve this, this denominator will have reciprocal, that is BC over AC into AC over AB. This AC and AC will be cancelled. So BC over AB. So now let's check. BC over AB is our tangent A. Okay, so we can say that these are another formula that are the relationship between more than one trigonometric ratio. So cot A is 1 by tan A, secant A is 1 by cos A, cosecant A is 1 by sin A, and tan A is sin A over cos A. Always remember one thing, that these ratios depends on the angle under consideration. If we are taking angle A, then P and B, that is adjacent side and opposite side, are different. But if we use angle C, then this will be the opposite side and this will be our adjacent side. So always remember that any ratio that you are considering, suppose sine of A is P by H. P is opposite side, H is hypotenuse. So sine is ratio of opposite side or perpendicular with hypotenuse. So whatever angle you are considering, so accordingly you have to substitute the values of opposite side, that is perpendicular, base, that is adjacent side, and hypotenuse. So always make sure that you are putting the values of opposite side, adjacent side, hypotenuse correctly. So let me explain again. That is what I am saying, that if I am taking this angle, so this is C, okay, this is A and this is B. If we are considering this angle, okay, so the side opposite to angle B will always be hypotenuse. Now this angle is under consideration, so angle side opposite to angle C. So this is your opposite side now. Opposite side or perpendicular. Okay. And this BC will be now adjacent side. So this is adjacent. Okay. Or base. So values of these ratios will change accordingly the values of your opposite side and adjacent side. So I hope this topic is clear to you, that what are the different trigonometric ratios and how to find their values in our right angle triangle. So I hope now you are familiar with the different trigonometric ratios. Now let's have a quick recap of whatever I have explained. So overall we can say that trigonometric ratios of an acute angle of a right angle triangle is a relationship between the angle and the length of its sides. So there are certain points that you should always remember. Sine A or any other trigonometric ratio, that is cosine A, secant A, tan A, this means sine of angle A. So sin A means sine of angle A. Cos A means cosine of angle A. It should not be read as product of sine and A. Individually, sine and A has no meaning. Sine A together means sine of angle A. Second is, if we increase the length, values of angle A remains same. Suppose we are taking this triangle, okay, let it be A, B, C. If I increase the length of the sides, that is, suppose AB is further extended to D and this is also extended like this, okay. So now let's see this angle again, that is sine of angle A. So even if we are increasing the sides, that means angle is constant. If angle is constant, then the trigonometric ratio is also constant. So this is the main key factor that is helpful in using trigonometric, that is, irrespective of the length of the sides, the angle remains constant. If angle is constant, trigonometric ratio is also constant and we can use them as standard values. Okay. Third thing is, sometimes there is confusion that sine A whole square, instead of writing like this, we always write like sine square A. So this and this are same, but instead of writing this, we will write square here. So angle A is separate. This is sine square A. Sine square A means sine A value multiplied with sine A. Okay. So this is actually written like this, but in trigonometry we will write it like sine square A. Okay. So whenever you find sine square A, tan square A or any other ratio, this means the value of the trigonometric ratio should be squared. Okay. One more thing is, sometimes instead of using this A, angle C or angle B, Greek letter is used. This is this thing like this, and this is referred as theta. So angle theta means if I write here theta, so sine A or sine theta is same thing. Means instead of writing sine of A, I will write sine of theta. Theta is your angle under consideration. So instead of writing these vertices, we can write these letters also. Okay. So these points you should always keep into your mind whenever you are solving questions related to trigonometry. So now let's take an example like how to use our trigonometric ratios. So let's see an example. Given tan A equals to 4 by 3, find the other trigonometric ratios of angle A. So this is very important type of question that will come under this topic. This any ratio will be given to you. It may be sine, cos, tan, cot, secant, cosecant. Any one ratio is given and you have to find the remaining 5 ratios. So how to start is always first make a triangle. Okay. So whatever angle is given to you, that vertex should be your acute angle. Suppose in this case angle A is needed. So I have drawn a triangle ABC right angled at B. So this is our angle A which is under consideration. So now tan A is equal to 4 by 3. And what is the value of tan A? As I have already explained, P, B, P over H, H, B. Okay. So now this is sine, cos, tangent. So this is the ratio that we will use, that is perpendicular over base. But first we should identify which one is perpendicular side or which one is base side. Perpendicular is also opposite side and base is also adjacent side. This is the angle, so the side that is opposite to angle A, so this is your opposite side, or we can say perpendicular. Okay, and this AB is adjacent or base. Okay, and opposite side for right angle will be referred as hypotenuse or H. This is the first step, that is to identify which is opposite side or P, which is base or adjacent side, and which one is hypotenuse. So now tangent is perpendicular over base. Perpendicular is BC over base, that is AB. So now what to do? We know that these are the ratio. So after simplification we should always get 4 by 3 if we are dividing BC with AB. So let BC, that is numerator, we will take this value, that is 4K, and AB as 3K for K to be any positive number. Because if we take K as 2, then 4 into 2 8, 3 into 2 as 6, 2 will be cancelled, we will be left with 4 by 3. So always assume like this. So BC, this is 4K, okay, and AB is 3K. So first of all we should find the length of all the sides of a triangle. So we have AB, we have BC, we should find AC. How to find? Using Pythagoras theorem. So apply Pythagoras theorem on triangle ABC. And what is Pythagoras? Hypotenuse square, and hypotenuse is AC. Hypotenuse square is equal to base square. Base is AB. So this is AB square plus perpendicular square. Perpendicular is BC square. So Pythagoras theorem is hypotenuse square is equal to base square plus perpendicular square. So now we will put the values. AB is 3k. So this is 3k square. BC is 4k square. Okay. So 3k square is 9k square. This is 16k square. So 16 plus 9 is 25k square. And this is AC square. So what is AC? This will be plus minus square root of 25k square. So this is plus minus 5k. But since k we have taken as positive number, so we will ignore minus 5k. So what is AC then? This should be 5k. Okay. So we get AC as 5k. Now we have the length of each side. We can find our ratios. So let's see how to do that. First ratio is sin A. Next is cosine A. Next is tangent, that is already given. Next will be cot A. Okay. Then is secant A and cosecant A. So let's start. Sine is this value, that is P over H. And what is P? This is 4k over H. H is hypotenuse, that is 5k. So after simplification we will get 4 by 5. See how easy it is. Cos is base over hypotenuse. Okay. So base in our case is AB. You can write like this also. AB over hypotenuse is AC. AB is 3k. This is 5k. K will be cancelled. So answer is 3 by 5. Right. Next is cot A. Cot AC. This is sine, cos, tan. Then this is cot. Or cot is reciprocal of tan. Anyway, you can use it. We already have value of tan. Cot is reciprocal of tan. You can write like this also, 1 over tan A, or you can use base over perpendicular. This is entirely your choice. So 1 over tan A is reciprocal of this value. So this will become 3 by 4. Correct? Next is secant A. Secant is here. This is reciprocal of cos. Okay. Cos we have calculated as 3 by 5. So what is reciprocal? It will be 5 by 3. So you can write here, this is 1 over cos A and this will be 5 by 3. Okay. Next is cosecant. Cosecant is this last one. Okay. This is hypotenuse over perpendicular or reciprocal of sine. So reciprocal of sine is 4. This is 4 by 5. So reciprocal will be 5 by 4. We can write here 1 over sine A. This is 5 over 4. And that's it. This is our question. So I repeat what we have done. Whatever ratio is given to you, using Pythagoras theorem, find the length of the missing side. Okay, you should identify which one is your perpendicular or opposite side, which one is base, that is adjacent side, and then use your formula, that is PBP over HHB, to find the values of your trigonometric ratios. Once, basically you should find 3 values, that is sine, cos and tan. Once you have these values, just do the reciprocal to find the remaining ratios. That is, cotangent is always reciprocal of tangent, secant is reciprocal of cos, and cosecant is reciprocal of sine. And after putting the values, we can find the values of our given ratios. So I hope trigonometric ratios are clear to you. Many questions related to this topic we will cover in our first exercise. This is all about this video. See you in my next video with the next topic of this chapter. Thank you.